In the world of software development and system design, clarity is paramount. Imagine a world without blueprints for buildings or musical scores for orchestras. Similarly, complex systems, whether software applications or business processes, require a structured approach to design and communication. UML, or Unified Modeling Language, acts as a blueprint for systems. It's a visual language that provides a standardized way to visualize, construct, and document the artifacts of a system. Imagine UML as a universal language that everyone involved in a project can understand, from developers to stakeholders. Whether you're building a mobile application, designing a complex business process, or even planning a large-scale software system, UML provides the tools and techniques to model your system effectively. Just like any complex structure, systems are built from fundamental components. In UML, these fundamental building blocks are called structural elements. They represent the static parts of a system, the entities that exist, and the relationships between them. At the heart of structural elements are classes. Classes are like blueprints for creating objects. They define the properties or attributes and behaviors or operations that objects of that class will possess. For instance, a car class might have attributes like color, model, and speed, and operations like accelerate, brake, and turn. Objects, on the other hand, are the actual instances of a class. They are the real-world entities that the class represents. If car is a class, then your specific car, with its unique color, model, and speed, is an object of that class. UML also includes components, which are self-contained modules of functionality. Associations between classes and objects depict the relationships and interactions between them. Let's dive deeper into the core concepts of classes and objects. A class, as mentioned earlier, serves as a blueprint. Imagine you're building a house. You wouldn't start laying bricks without a plan, would you? The plan in this case is the class. In UML, a class is typically represented as a rectangle divided into 3 sections. The top section contains the class name, the middle section lists the attributes or properties, and the bottom section lists the operations or methods. Attributes define the characteristics of an object, while operations define what an object can do. An object, on the other hand, is an instance of a class. Going back to our house analogy, once the house is built, it becomes an object. Each house built from the same blueprint will have the same basic structure, but might have different colors, sizes, or other specific features. In UML, an object is represented as a rectangle with the object name underlined and often followed by a colon and the class name. Classes and objects are fundamental to understanding and modeling systems. While structural elements provide the skeleton of a system, behavioral elements bring it to life. They describe how a system behaves and interacts over time. Use cases are a prime example of behavioral elements. They describe a system's functionality from the user's perspective. Imagine you're withdrawing money from an ATM. The use case would outline the steps involved. Insert card, enter PIN, select withdraw amount, get cash. State machines, another behavioral element, illustrate the different states an object can be in and how it transitions between those states. For example, a traffic light can be in one of 3 states, red, yellow, or green. The state machine would show how the traffic light changes states based on certain conditions. Activity diagrams resemble flow charts and depict the flow of control within a system. They illustrate the steps involved in a particular process or activity. Sequence diagrams focus on the interactions between objects over time. They show the order in which messages are exchanged between objects to accomplish a specific task. In any system, the individual elements don't exist in isolation. They interact and relate to each other in various ways. UML provides several relationship notations to represent these connections. Generalization is like inheritance in object-oriented programming. It's a relationship between a more general element, or parent class, and a more specific element, or child class. The child class inherits the properties and behaviors of the parent class, but can also have its unique characteristics. For example, a sedan class could inherit from a more general car class. Association represents a general relationship between 2 elements. It indicates that they are connected or know about each other. For instance, a professor class and a student class could have an association indicating that professors teach students. Dependency signifies that one element depends on another for its implementation or functionality. Changes in the independent element might affect the dependent element. For example, a report generator class might depend on a database connection class to retrieve data. Aggregation represents a whole-part relationship. Where one element is composed of multiple instances of another element, the part can exist independently of the whole. For example, a car class might be an aggregation of wheel classes. Section 6. The power of use case diagrams. Among the various UML diagrams, use case diagrams hold a special place. They provide a high-level view of a system's functionality from the user's perspective. Imagine you're developing a new e-commerce website. A use case diagram would visually represent the various interactions users can have with the system. For example, users can browse products, add items to their cart, check out, track orders, and manage their accounts. The actors, represented as stick figures, are the external entities that interact with the system, such as customers, administrators, or other systems. Use case diagrams are powerful tools for communication between developers and stakeholders. Section 7. Importance of UML enhancing communication and clarity. In the realm of system design where complexity can quickly escalate, clear and effective communication is paramount. UML emerges as a beacon of clarity, providing a standardized visual language that transcends technical jargon and fosters understanding among stakeholders. Imagine a group